Hey guys, welcome back to 100 Days of Code. Today is day 30, and to mark this milestone, we're going to be learning about some more advanced Python topics, such as errors, exceptions, and also we're going to be learning how to save and load JSON data. So that's all yet to come. First, we're going to be taking a look at some of the errors we've been getting and how to avoid crashing our app by handling those errors. Then we're going to take a look at this particular data format called JSON. And this is probably one of the most widely used data formats for transferring data across the internet between applications. And this is going to be something that's going to be helpful not just in Python, but in a lot of other programming languages as well. And once we've understood all of that, then we're going to put it together. We're going to use it to improve our existing password manager. By the end of today, not only will we be able to save websites, generate passwords, and add it to our database of passwords, but we're also going to be able to search through that database. So we could type in the name of a website, hit search, and it'll tell us what the email and password is that we need to use to log on to that website. Plus, we're going to make this a lot safer by handling some of the exceptions that could happen and make sure that in all circumstances, our app will work exactly as expected. So all of that and more is coming up. Head over to the next lesson and we'll get started by learning about errors and exceptions. In this lesson, we're going to talk about errors and exceptions. I'll show you what happens when a program encounters different types of errors and how you can write code to handle these situations. To begin, I've created a brand new project called Day 30. And I've created my main.py file. Now notice how inside my project there is only one code file at the moment. There is no data files, no text files, nothing. In this situation, if I was to try and open up a particular file that doesn't exist and I try to read it, what do you think would happen? So we're going to use our normal syntax with open, and let's just make up a file name. So a file.txt. And I'm going to save that as a file, and I'm going to take this file and try to read from it. Right now, if I run this code, then this is what happens. I get a traceback and I get a error, which is the file not found error, which kind of makes sense given that there really is no such file existing inside our folder where we're telling it to search. That's not great. And if this happens somewhere within our actual program, so here I've got the password manager completed project from yesterday. If in this case I made a typo in this word, so instead of data.txt, I wrote data.txt, and instead of the append mode, I had the read mode. Well, in this case, what would happen is exactly the same thing. So I could have a website, have a password, but as soon as I hit add, then we get our file not found error. And notice how as soon as that error happens, it actually doesn't continue, because on the next few lines, we've actually got these two lines of code which deletes the entry inside the website entry and also the password entry. But those lines of code are not being carried out because it's hit a stumbling block. It has not found the file that we're trying to open and we're trying to read. So I'm going to restore the code to how it was previously, but this is a good point to start thinking about errors, because we've come across a lot of errors, right? Including errors like key error. So for example, if we have a dictionary that has just one key value pair and we somehow try to get a value from that dictionary by tapping into a key that doesn't exist, then when we run this code, we will get a key error, right? It can't actually pick out the value from this dictionary because this key that we provided does not exist in that dictionary. Now, some of the other popular ones that you've seen are the index error. So in this case, we have a list and we basically are trying to get hold of an item from this list at an index that doesn't exist. So remember, the index starts at 0, 1, 2, and 3. There is nothing at 3. So again, when I run this, we get an error, and this is an index error. And the final error that we've probably been used to seeing is the type error, where we're trying to do something with a particular piece of data, but we cannot do that thing with a particular data type. Let's say we have a piece of text, ABC, and we try to print this text plus the number 5. So a string plus an integer, and again, when I hit run, we get a type error. All of these types of errors we've actually come across already, and all that we've done so far is just used it as an indicator to tell us, wait a minute, something's not quite right, we gotta go and fix our code. But life doesn't really work out so neatly most of the time. In a lot of cases, it actually follows Murphy's Law, which states that anything that can go wrong probably will eventually at some point go wrong. So we have to plan for these eventualities, just as, your car is probably not going to break down, but you need breakdown cover just in case that it does happen. In programming, what we can do is we can catch these exceptions. When something goes wrong and in that moment we catch that exception, then it doesn't have to fail catastrophically. We can actually fail more gracefully, or we can decide that something else should happen. Here's what the code looks like when we're dealing with these exceptions. We have try, except, else, and finally. These are the 4 keywords that are really important when it comes to handling exceptions. Now, the first keyword, try, comes before a block of code where you're executing something that might cause an exception. So basically, you're trying to execute a piece of line. In most cases, it probably will work, but sometimes it just might not. Now, the next step is to define the except block. So this is the block of code that you want the computer to execute if there was an exception. If something went catastrophically wrong and it was not the way that you expected it to go, then carry out this piece of code. Now, the else keyword allows you to define some code to execute if there were no exceptions. If you tried this thing that might fail, but actually it didn't fail, you succeeded and there were no problems, well then in this case, you're going to do whatever is inside the else block. And then finally, we have the finally keyword, which basically is just a block of code to carry out no matter what happens. If this thing that you tried failed or if it succeeded, finally doesn't actually care. So no matter what happens with trying this line of code, this finally block is always going to be executed, and it's usually used for cleaning things up or tidying things up at the end of some sort of code execution. Let's take our file not found exception and let's see how we can make this a lot safer by catching that exception. The thing that we're going to try is to open up this file. Instead of using the with format, I'm actually just going to straight up create a file and set it to open this particular file path. So a file.txt. Now, this is the line of code that can cause an error, and it will cause an error in our case because we don't have a file called a file.txt. So this line of code is going to go inside a try block. So let's indent that. So this is the line of code that we're going to try. Now, the next thing we'll define is the except block. Basically, once we've tried running this line of code, and if there was an exception that was thrown when we were running it, like the type error, or in this case, it would be a file not found error, well then in that case, we're going to do something different. We're going to, let's say, print there was an error. So now let's run this code and you can see straight away there was an error because this file doesn't exist. So this failed and therefore this line of code was executed. It's almost a little bit like we have an if statement, and the if statement is checking to see if something fails. Well, in that case, this is where it looks to see what it should do next. Now, just printing there was an error is kind of pointless. What we actually want to do is to make sure that we don't actually fail, so that whatever happens, we succeed. So if there is a good alternative, then that's what we're going to put inside the except block. What we're going to do instead if this file doesn't exist and we can't open it, is we're just simply going to create it. To create a new file, remember that you can open up the file and you can open it using the write mode. Because when you're inside write mode, then what this open method is going to do is it's going to try and find this file and open it, but if it doesn't exist, it's just going to create it. Right now, if I run this code again, I want you to watch inside the day 30 folder, because as soon as I hit run, you'll notice that a file.txt gets created. Because we tried opening it, it didn't exist, so it went into the except block and it actually just went ahead and created this file from scratch. Now, this file is of course completely empty because we haven't told it to do anything, but we could in fact get our file and write something to it. We can put all of that inside the except block if we want to. Now, one of the things that's giving us a warning here with the except keyword is if you hover over it, it tells you that this is too broad an exception clause. And according to the PEP 8 recommendations, it tells us you should never use a bare except. And the reason for this is because when you have an except clause, then it's actually going to ignore all errors. For example, if inside here, let's say I decide to do something that was also going to create an error, but not the same kind of error. So now I have a dictionary with a key and a value. But let's say I try to print some sort of value from that dictionary and I use a non-existent key. So you can see that this dictionary does not have a key that is named this. So this line is going to actually give us a key error. But now notice what happens when I hit run. Absolutely nothing. I don't get any errors. And the reason for this is because inside the try block, it's first trying to open up this file. And indeed that file exists. So it moves on to the next line. It creates a dictionary called a dictionary, and then it tries to get hold of this value with this key from that dictionary. Now this line actually fails and creates an exception. But that exception is called right here, and it simply tells it to go ahead and create a file called afile.txt, which it will go ahead and do. So this is not what we want at all. Instead, we want our exception to catch a specific situation. We want to say that in the exception that we have a file not found error, then this is what we want to do. And now if I run the code again, you can see we're now getting that key error, and it's telling us that this thing worked, so it didn't generate a file not found error, but the next thing that it tried, when it tried to print this value, it got a key error. So we can actually have multiple exceptions. Instead of just except file not found, I can also say except key error, and in this case I'm just going to print that key does not exist. Now if I hit run, I get no errors, but I do catch that exception and I have this print statement executing. In addition to simply catching an exception using except, you can also get hold of the error message that would have normally printed had we not had the exception caught. Normally you would get key error and it would give you a message that tells you which key was the problem. If we catch our exception and we still want to get hold of that error message, then we can say except key error as error message. And this means we can get hold of the error message that was generated from this exception if it does occur. Instead of saying that key does not exist, we can now take this as an F string and we can say the key, and we pass in the error message right here. So now I hit run again and it tells me the key SDF does not exist, which is a lot more useful than simply saying the key does not exist. So you can try, you can catch exceptions, you can catch other exceptions, you can also get hold of the error message and use it when you catch the exception. Now the next keyword we mentioned was the else keyword. And this block of code is going to execute when the thing that you're trying all succeeds. So if it managed to open up the file, it managed to print this item from the dictionary, and there were no exceptions that were thrown from this block of code, then it's going to jump to the else block. So what else do you want to do? Well, maybe I actually want to read from this file. So file.read, and we save this as our content. And then we go ahead and print our content. Now, remember, if this file doesn't actually exist, this else block is never going to be triggered. So if I go ahead and simply delete this file and I hit run, you can see that this else block does not occur because it tried to do this, it failed, and so it ended up jumping into the except block and it generated that file. But now that that file has been created, the next time I hit run, then this line of code is going to succeed. And now it catches the next error in that try block. So if I change this to a key that it actually will recognize, then that next line also succeeds, and finally it gets to this block and it actually prints out the thing that's inside a file.txt, which is just the word something. So we've now got try, except, else, and the last thing I want to show you is the keyword finally. So this finally is basically some code that's going to run no matter what happens. And in our case, the most appropriate thing to do here is actually to close down the file because we're not using the with keyword. So our file would actually stay open if we actually had an exception. And I'm going to go ahead and print file was closed. Now our code basically will open up this file, and no matter if it succeeded or if it failed, it's going to close down that file so that we don't end up with an open file that we're not doing anything with. So finally is not often used, but sometimes it can be useful when you want some code to execute, no matter if the code you're trying is succeeded or failed. In the next lesson, I'll show you how you can raise your own exceptions. In this lesson, I'll show you how you can generate your own exceptions in case your code encounters unexpected situations. So these are the 4 key words that are most important when it comes to error handling and catching exceptions. The final keyword that is related is one called raise. And what this allows us to do is to raise our own exceptions. For example, let's say I decide that at the very end of all of our file, no matter if this file went through or if it didn't, if there were an error or if there was an error, I'm still going to raise an exception. And to raise an exception, all I have to do is tap into one of the known exception classes. So let's say I just decided to raise a key error. Now when I hit run, you can see no matter what happened, and in fact there is no error, I decided to raise this error, and that's what I see right here. I could change that to a type error, and that is what will crash my code. And I can even specify a message along with this error. So I could say raise a type error, and let's just say the message is, and you can see now when it runs, it hits that type error and it says this is an error that I made up. So when might you want to raise errors? Well, let's comment out all the code that we have, because we have that type error at the end, so it's always going to crash the code no matter what. So let's comment it out and let's start from scratch. Let's say that I decided to calculate the body mass index, or the BMI, of somebody, and I'm getting them to input their height as a float, so this is going to be their height in meters, and their weight as an integer. Now, I can calculate the BMI by taking the weight divided by height times height. And you can either do this and wrap it inside some parentheses, or you can use the power function, or even better, you can actually use the built-in exponent, so height to the power of 2. No matter which way we use, we can print out the BMI, but if I provide a height that is just an unrealistic, non-human height, let's say they were 45 meters tall, like some sort of 4-story building. And then I gave them a weight. So let's say they are 67 kilos. Then obviously a mistake has been made somewhere in the height, right? Because this is just not within the normal human range. This is like Godzilla's height. If I go ahead and hit enter, you can see that we get a BMI and it is calculated correctly and there are no errors because everything is perfectly valid other than the fact that this height should not really ever go over 3 meters. In this case, we might want to raise our own exception. So we can go ahead and say that if the height is greater than 3 meters, well, in that case, it's probably not a valid height. So we can go ahead and raise a value error. So this is an error that says that whatever value was entered as the argument is probably wrong. And we can accompany that with a message: human height should not be over 3 meters. Now when we run our code and the user mistakenly types a wrong height, then it's going to actually give us this error and it won't proceed to give them an inaccurate BMI. So this is how you might raise your own exceptions when there are certain things that are not caught by the code because it's perfectly valid code, but it's in fact going to generate the wrong result. Now that we've seen all of these aspects of exceptions, I want you to have a go at catching some exceptions that can commonly occur. So head over to the next lesson where I've got an exercise for you. Now that you've learned some of the theory around error handling and catching these exceptions and handling them, then we're going to put all of that knowledge to practice by completing a couple of code exercises. So you're going to head over to the Replit coding exercises, which you'll find in the course resources. And the one that I want you to complete is day 30.1, index error handling. So this is the starting code. And if we hit run, you can see that immediately we get an error. And it is the index error telling us that list index is out of range. Your job is to fix this code and catch the errors so that it no longer causes a crash like this. Have a look through the instructions, pause the video, and complete the challenge. So the problem here is that we're calling this function makePie, which takes an index number, which is used to pick out a particular item from our list of fruits. Now, if we try to get a hold of the item at index 4, which is way beyond the number of items that's in this list, then we're going to get this index error. What we're going to do instead is when this happens and we try to pick something out of the list that doesn't exist, we're just going to print out the default output, which is just fruit pie. The part of our code that is prone to errors is this line right here. So that is what we're going to trap inside a try block. So the idea is try this, and if it fails, so in the case where there's an exception, then do something else. Now, accept the fact that we're not just going to use a broad stroked except, because that means it's going to catch all errors and it's going to do this no matter what type of error. Instead, we want to be more specific and we want to say except in the case of an index error, same as what we see being thrown right here. Well, then in that case, we're going to do something a little bit different. We're just going to print the words fruit pie. However, if this thing that we tried succeeded, then we go into the else block. And in that case, we're going to get hold of the fruit and we're going to add pie to the end of it. So now if I hit run, you can see that we get fruit pie being printed and there's no more errors and our program is no longer crashing. So did you manage to complete this coding challenge? If not, be sure to go back to the last lesson and review some of these keywords and what they're used for. Otherwise, head over to the next lesson where there's another coding challenge waiting for you. Now that you've handled index errors, we're going to handle a different type of error in this coding exercise. We're going to look at key errors. So in this case, again, when I hit run, my code is going to crash and I get a key error. And the reason is because I am looping through this list of dictionary objects. And what I'm trying to do is I'm trying to get a hold of all the likes from each of these Facebook posts. So imagine you have a whole bunch of Facebook posts and you want to know how many likes did you get in total this month. Well, you might get some piece of data that looks a bit like this, a list of dictionaries. And what you're essentially trying to do is you're trying to loop through every post inside that list, and you're trying to get hold of the total likes by adding the existing number to the number of likes for each post. The key error occurs because some of these posts actually have no likes, so that key doesn't actually exist, and that's why we get this error. So I want you to have a look through the instructions and see if you can fix this code so that we no longer have these errors. Essentially, if a post doesn't have any likes, you're going to treat it as 0 likes. Pause the video and complete this challenge. Okay, so the key part that we need to fix is inside here. Now, what we're going to do is inside this for loop, we're going to add a try statement so that this line of code is inside the try block. This is the thing that we're going to try, and this is the particular part that might fail. Now, if it does fail, we can catch it using an except, but we're going to be more specific than just except. We're going to say except in the case of a key error, which is the problem that we're coming up against right now. Basically, if we try to fetch a particular value from this dictionary using a key that doesn't exist, then this is the block that we're going to enter. And so inside this block, we're going to either add 0 to our total likes, or alternatively, an even easier way is we can just say pass. So in the case where we generate a key error, we're just going to skip, and then the code is going to continue running, which means it's going to get to the end and it's going to loop back to the next post in our list of posts. So now if I hit run, you can see that I actually get the total number of likes being printed, because it's looping through all the posts in our list, and for the ones which have that key likes, it adds the number from the value of that key to our total number of likes. But if we get a key error, then we simply pass and we don't add any numbers at all. This is how we can solve this particular situation. In this solution, it doesn't matter if you use pass or if you simply said total likes plus equals 0. It doesn't actually matter what you do as long as you handle this particular exception and you do something to address the fact that some of these posts don't have a like key. Have a look through the solution code if you want to on Replit, but otherwise head over to the next lesson and we've got a final coding challenge for you to try out exception handling. I'll see you there. Now, for the final coding exercise, we're actually going to jump into a previous project that we created. This is the NATO alphabet project that we created a few days ago. And it's pretty simple. All it does is it takes the data that's inside this NATO phonetic alphabet CSV, and it uses that to create a dictionary so that we have each letter as the key and the actual phonetic alphabet as the value for each of those keys. Now, if I go ahead and hit run, you can see that the entire phonetic alphabet dictionary is printed here, and this is the structure of that dictionary. Now, the next thing it asks us is to enter a word, and it takes that word and creates a new list using list comprehension that matches each of the letters to the correct phonetic alphabet. So Angela becomes Alpha November Golf Echo Lima Alpha. So you should remember all of this from creating this project a few days ago. Now, what we're going to do is we're going to update and refresh this project so that it's even better than before. Now, if you don't have access to the final project of this NATO alphabet project, then don't worry, just head over to the course resources for today's lessons and you'll find a starting file that matches what you see here precisely. Now, your job is to address a particular situation. Because we're relying on the user to enter a word, then if they enter something that is actually not in this dictionary, let's say they entered just a number 1, 2, 3, 4, then we will get a crash and we get a key error in this case. Now, what we want to happen instead is for us to enter a word, and we enter something that's complete nonsense. We hit enter and it tells us that, sorry, only letters in the alphabet, please. And then it goes back to give us that same prompt again. And if we keep refusing and we keep typing numbers, then it's going to continuously give us this feedback until we actually end up typing something that contains only letters in the alphabet, and it actually generates the phonetic alphabet for us. This is the goal that we're trying to achieve, and in order to do this, you're going to have to use your skills of exception handling. Have a think about how you might achieve this, pause the video, and complete this challenge. Now that we know what we're aiming for, the next step is to actually try to get there. Now, we know that the part of the code that is prone to error or can occasionally be problematic is this line right here, because we're going through this phonetic dictionary and we're passing it a key. And that key depends entirely on what the user puts into this input. So that means if they put something that is a number and it doesn't exist inside the phonetic dictionary, that's when we get our key error. So this is the line that we want to put behind a try block, like this. And when we try out this line, and if it actually fails and we end up with an exception, then we want to catch that exception. But we want to catch the specific exception, which is the key error. Now, what do we want to do when we actually have an exception, when that key doesn't exist? Well, it means that the user entered something into the input that was not a letter from the alphabet. So we're going to give them some feedback. We're simply going to use a print statement to print, sorry, only letters in the alphabet, please. Hopefully that way they will learn and they will only write letters instead of trying to type other things like symbols or numbers. Now, if everything went well, so in the else case, then we actually want to print out the output list, because if this line succeeded, then we will have that to print out to the user. Now, the only problem here is if we run the code as it is right now, we can enter a word. So let's try something that's not a word, and we get that feedback, but our code ends. So if we want our code to repeat so that we ask the user for a word again, then we're going to have some sort of mechanism like a loop or a function. So I think in this case, the best thing to do is actually to create a function, which I'll call generate phonetic. And this function is going to contain all of this code. So in order to run this function, we of course have to call it outside of the function. So once the code runs down to here, it sees this line and it will run all the code inside this function. But what we also want to do is, if there was the case of a key error where the user typed in something wrong, then we want to give them the opportunity to type in something again. So we want to be able to run this line of code again. The easiest way of doing that is to simply call this function right here. So that way, if they typed in something wrong, we give them some feedback, and then we go to the very start of this function once again, and we get them to type in a new word using this input. And then we can see if that was valid or if it was not, and deal with that accordingly. So now when we run our code, it won't generate any errors, but instead it gives me some feedback and tells me to enter another word. So this is more of a real life implementation of error handling, making sure that we are validating and checking the user's inputs and addressing these situations ahead of time using exception handling. Now that we've taken a good look at exception handling, in the next lesson, we're going to go back to our password manager project and use the skills that we've learned to improve it even further. So for all of that and more, I'll see you on the next lesson. The goal is to take our password manager to the next level. And in order to do that, we need to add a search functionality. It's not good enough just to look through the data file anymore. What we want to be able to do is to type a website into the website entry and then hit search, and we get a pop-up showing us our email and the password that was saved for that website. So this is the goal. But where we're currently at is we have a text file which contains the name of the website, the email, and the password. This is very difficult to search, and this is a really terrible format to work with. So we're going to be leveling up our data storage in our password manager. And we're going to switch from saving data straight to a text file to a fancier data format, which is called JSON. Nope, this is not the latest, hottest DJ on the block. It's actually JSON, which stands for JavaScript Object Notation. This was something that was designed originally for JavaScript, but because it has such a simple structure and it's so easy to understand and work with that it's been adopted by many, many different fields, including Python. This is probably one of the most popular ways of transferring data, especially when you're transferring data across the internet. So this is what we're going to be learning about. And for those of you looking at this slide, you might have already realized that it's kind of similar to the dictionaries that we've been working with in Python, right? A JSON is essentially composed of a bunch of nested lists and dictionaries, and it has that key value pair data structure. This is essentially what we're aiming for, so that we can store our data in this format, and we'll be able to easily load up this data and search through it for the particular website that we want the information for. To work with JSON data in Python, we can use the inbuilt JSON library, and we're going to use it to write, read, and update data to a JSON file. To begin, I'm going to simplify our code a little bit. I'm going to get rid of this message box, which asks the user OK or cancel. We're just going to assume that once they click add, then they're happy with the email and password. So now that we've cut down that little bit of code, it makes this a little bit easier to understand. All that we're doing here is we're checking to make sure that the length of the website entry and the length of the password entry is equal to 0. And you might still have the length checking for the email entry, but remember that at the end of previous lessons, we actually inserted a default value. So we can actually skip that check as well if you wanted to. The reason why we want our code as simple as possible is so that when we're working with the JSON and we're learning about how to work with it, as long as everything else is simple, then we can focus on the new things that we're learning. In this case, instead of opening a data.txt file, I'm going to change the data format to a .json. And instead of using the append mode, I'm going to use the write mode, because I'm going to be writing to this data.json file. Now, in order to write to a JSON file, we don't use this line of code. Instead, we use a method called json.dump. And that, of course, requires us to import the JSON module, which should be inbuilt to Python, so you don't actually have to install it. Now, once we've imported our JSON module, we can say json.dump, and this takes a number of inputs, but the most important are the things that you want to dump and the file that you want to dump it to. The data that we want to put in here should go in as a dictionary. Essentially, what we want to create is a new dictionary, which I'll call new data, and it's going to be a nested dictionary. So the first level key is going to be the website, because this is what we're going to be searching through eventually. And the website is going to itself contain a dictionary. Now, this dictionary contains two keys, the email and also the password. The values for each of these are pretty self-explanatory. It's the email that we got from this line of code, and the password is the password that we got from this line of code. Now that we've created this new dictionary called new data, well, that is what we're going to use to dump into our JSON file. Let's go ahead and dump our new data. So that's the first input. Now the next input is going to be the data file that we want to put it into. So that is going to be the file that we opened up inside this line. Let's provide our data file as the location to dump this data. And now if I go ahead and hit run, and I create a new entry for my Amazon website password, generate the password, hit add, then you can see that we've got our brand new data.json file that's just been created. So just as a quick reminder, when you open a file in write mode, if that file doesn't exist, it will actually create it. So we've created this new file, data.json, and we've dumped the data that we entered into that file. So now if I open this up, you can see we've got a JSON format in here, and we've got our Amazon website and all of its associated data. Notice how this data is not very easy to read for a human. So we can actually improve that by adding one other argument, and it's an argument called indent. This we can provide the number of spaces to indent all the JSON data so that it becomes much easier to read. So I'm going to go ahead and delete everything that's in here, and I'm going to run the code again. And this time, once I save this data into my data.json, you can see everything is all indented and it's much easier for the human to read. Now that we've seen how we can write data to a JSON file, the next step I want to show you is how you can load data from the JSON file, or how to read from it. To read JSON data, we use the JSON module and we call the load method. So I'm going to go ahead and comment out this line of code. And now that I've actually got some data in my json.data file, I'm going to try and read from it. We call the json.load method and we pass in the file path, or you can see here the FP. So that's the only required input. The file that we're going to pass in is our data file, which we opened up over here. And what we're going to do is we're going to change this from write mode to read mode. Once we've loaded up the data, we're going to save it inside a variable called data, and then I'm just going to print it out. So when I hit run right now, and I simply add any sort of gobbledygook, but as long as I can hit the add button, it's going to trigger this part of the code. And now if we take a look inside our console, you can see that data is being printed down here, but without any of these indentations or any of the formatting. Instead, what that load method does is it essentially takes this JSON data and converts it into a Python dictionary. So this data, if we actually do a type check on it, you can see has a type of dictionary. This is just a normal Python dictionary. So essentially we can use json.dump and json.load to serialize and deserialize from JSON data to Python dictionaries. And it allows us that free interchange of information. We change it into a JSON to store it, and then we take it out of storage and turn it into a Python dictionary to easily work with it in our code. Now that we've seen how to write, how to read, the last thing I want to show you is how to update data. Because if we have a new piece of data come in, we want to add to this JSON, but we don't want to overwrite it. But we also don't want to just append to the end of it. Because you can imagine if we had something that we just appended to the end, that's not a valid data structure. And that's why we're getting all of these errors. Instead of doing it manually, we're going to use the built-in method json.update. And here's how it works. So we've already got some data inside our data.json file. And I'm going to change this from read again back to write. And what we want to do is we want to take that data and we want to update what's existing in there with the new data that's being passed in. To do that, we first have to load up the data. So I'm going to uncomment this line. And once we've gotten hold of the data, we're going to say data.update. And we update it with the new data. What's happened so far is we have our data loaded up into a dictionary, we use the update method to update that dictionary with some new piece of data. Now, the next thing we want to do is we want to actually write that data back into this file. So we have to use this line of code using JSON.dump. But instead of dumping the new data, we're going to dump that data that we updated right here. Essentially, what we're doing here is a three-step approach. We're reading the old data, we're updating old data with new data, and we're finally saving the updated data. Here we've got two things happening. We've got reading and we've got writing. So we can split this code into two sections. First, we open the file in read mode, we get hold of the data, we update the data, and then we open up the file again, but in this case, we open it in write mode. This time, we're going to dump the data that we've updated over here into that data file using this particular indent format. And once we've written the file, then we delete all the text from our website and password entries. And these lines of code now replace our previous functionality where we were saving just plain text to our data.txt. Let's go ahead and run it and test it out. Currently, we have a single entry inside our data.json. So if we go ahead and add a new entry, say for eBay, and we generate password, click add. If we go back to our data.json, you can see how it's now been updated. This entire JSON has now been updated to have two entries, Amazon and eBay. It didn't just append it, it actually added it into the dictionary. And that's all thanks to that update method. And once it updated that data, then we told it to save the updated data back into the data file and wipe all of the previous data. So now that we're able to read, write, and update JSON data, the next step is to think about what situations might this fail. And one of the biggest problems we have at the moment is we're trying to open up this file, load up the data, and update it. But if we actually had no data in here, say the first time we ran our program, or indeed if we didn't actually have this data.json file, then you can see that the first time I run it and I try to save a password, then it's going to crash and we get some exceptions being thrown. But we know all about exceptions now, so in the next lesson, that's what we're going to tackle. For all of that and more, head over to the next lesson. So in the last lesson, we looked at how we can use this JSON format to save our data and to load our data into our program. But one of the problems that we have is if we run our program from scratch, where we don't have that data.json file created, then the first thing that it's going to encounter once it lands inside here is it's going to try and open a file that doesn't exist. And what happens then? We get a file not found error because there is no such file, data.json. So what can we do? Well, we already learned about dealing with exceptions and handling them so that we don't end up in these situations. So now it's time to put your knowledge into practice inside a real project. And I want you to think about how you can catch that particular exception, how you can get it to work so that if this fails, then we simply create a brand new data file. But if it does work, then we can simply load up the data, update the data, and write the data. So the actual implementation I'll leave up to you, but what you want to be able to do is to not have a data.json file and run your code and it would not crash, and instead it would create a brand new data.json file with the new data. But if you had already got some old data, then it should simply just update and write it to file. Pause the video and see if you can complete this as a challenge. This always starts with analyzing which part of our code is the part that's going to fail or likely to fail at some point. And in our case, it's this line right here. Opening this line in read mode is dangerous because if this doesn't exist, then we get that file not found error. So what we can do is we can put this inside a try statement. Try opening this file and try reading the data that's inside. Now, if this fails, however, then we can catch it, and we're going to catch a very specific type of exception, which is the file not found error exception. Now, when this exception happens, what we want to do is we want to create a new file, which is going to be our data.json. So at this point, remember, it doesn't yet exist, and we're going to open it in write mode. And this data file is going to be used so that we can write to it and we can dump our newly created data up here. Remember, when the user hits the add button, then everything they've typed in these entries gets aggregated into this dictionary, and that dictionary is what we want to dump into this new data file. So we'll get hold of that new data and we'll dump it into the data file. And again, we'll keep the indent to 4 spaces just so that we can read it more easily. Now, this is what should happen if the file's not found. But if the file was found and it already exists, then we're going to tap into the else statement. And then the else statement, what we're going to do is we're going to get hold of the data which we managed to get because this block of code succeeded. And in the else block, what we're going to do is we're going to update the data with the new data. Now, this else block is only going to be triggered if everything inside the try block was successful. So that means by the end of this block, we have this data which holds on to all of the existing data from that data file. And we update that data with the new data, which is this dictionary here. Now, after we've updated that data, we want to be able to open up data.json in the write mode and then dump this updated data from here into that data file. And then once all of this is done, no matter if there was an exception or if there was no issues, we're going to still need to delete everything that's inside the website and password entry. So we can even add a finally keyword right here. So this is the final code that deals with our exception. We have our try block, which can fail. We have our except block, which deals with any failures that occur. We have our else block, which has the code that needs to be run if there were no issues. And finally, at the very end, no matter if there was an issue or no issue, we have a block of code which clears our website and password entries. Now, you might have noticed there's a little bit of repetition here with the writing to file. So if you want to, you could in fact create a separate method somewhere up here. But I'm actually going to keep this as it is, just because I think when you look at this code, if you had any issues and you wanted to review it, this is much easier to understand and reason about compared to a separate function. Feel free to refactor this code and make it as short as you want. But this is the version that I'm going to keep just so that if you had any issues and you want to take a look at it, it's there for you and it's easy to see the try, except, else, and finally blocks with all of the code together in one place. Now, in the next lesson, we're going to be completing the functionality of our password manager. We're going to add that all-important search functionality, which is going to look through our JSON, fetch the results for a particular website, and then show it to us in a pop-up. So for all of that and more, I'll see you on the next lesson. In the previous lessons today, we looked at how we can use the JSON format to store and load data into our program. We also looked at how we can use the try, except, else, and finally keywords to handle exceptions in our program, to make sure that it doesn't fail and end up crashing our program so the user ends up with a bad user experience. Instead, we can anticipate the things that might happen. For example, the first time when we run our program, we might not have a data.json file, and we deal with it accordingly. Now, all that's left to do is to put in the last bit of functionality, which is the search functionality. Because after all, we don't want to be digging through a JSON file to find out our email and password combinations for the websites that we've stored. So what we want to be able to do is to add a search button, and it's going to look very similar in size to the generate password button, and it's going to be in the same grid column. Now, when we type in a website and we hit search, it's going to look through our JSON, find that data, load that data up, and look through it for a key that matches the one the user typed in. If they find it, then we get a pop-up showing up, and it tells us the email and the password that's associated with that account. So you've actually done all of this before, creating tkinter widgets, laying out tkinter widgets, creating message boxes or these pop-ups, and giving it a title, giving it a message. You've also seen how you can load JSON data and get the data in the format of a Python dictionary. Now, once you have the Python dictionary, then you can use your usual dictionary methods to try and get hold of the data that's inside. And finally, you also know how to deal with exceptions. So remember, there might also be an exception in this case, because if this was the first time that we were running this password manager, and in fact we hadn't stored any websites or any emails or passwords in our database, then if you hit search, it might actually just give you a file not found error as well. So there's quite a few components involved, but I'm pretty sure that you can actually get this to work. So the end outcome you're looking for looks something like this in terms of layout, and you should be able to test this so that when you start out without a data.json file and you hit search, it should tell you error, no data file found. But if you had saved a password under that name and you added it to the database, then you try to find it, then it should find you the email and the password that you saved. So this is what you're aiming for, and I'm pretty sure that you can do it with just a little bit of thought and a little bit of time spent problem solving. Once you're ready, pause the video and give this final challenge a go to complete the Password Manager project. Good luck. All right, so I hope you gave that a good go, and as I always say, if there's no struggle, there's no learning. So make sure that you've allocated at least 20 minutes to trying things out and figuring things out and debugging and just messing with the code yourself before you're coming to the solution. But all right, I'm going to walk through the solution with you together. And the first thing we're going to do is we're going to add a button next to our website entry. So right here. Now, notice how we've got our 3 columns in our grid system. So our search button is going to go in pretty much in the same column as our generate password button. So let's go ahead and create our search button. This is going to be a button with the text that says search. Now, once we've created that, let's go ahead and lay it out using the grid system. Now, this search button is going to go onto the grid in the same row as the website label and the website entry. So that is row 1. So let's go ahead and add row equals 1. And column wise, it's going to go in the same column as the generate password. So that is column 2. Now, if we run our code as it is, however, you'll see that the search button seems to be sitting inside the entry. And the reason is because initially when we created this entry, we gave it a column span of 2 so that it spans this second and third column. So we have to change that. Let's go and find our website entry and delete this column span equals 2. So now you can see that this has a column span of 1, so it's only in this middle column, but it's so large that it's pushing the rest of our layout out of the way. So what we need to do is we need to make this entry the same width as the password entry so that it will actually fit into our layout. So our password entry has a width of 21. So our website entry is also going to need to change down to a smaller size. Now you can see the entry is now the same size and it's looking a lot better. If you want, and this is really not strictly necessary, but I think it's quite neat, is you can tweak and adjust the width of the search button so that it's roughly the same as the generate password button. Now this button is this width because it's what is needed to accommodate all of the words in that button, but we can manually change the search button so that it's about the same width. And in this case, I'm literally just using trial and error to figure it out. Width is 10, looks maybe a little bit small. Let's try width of 13, and it looks just about right. Now that I'm done with my layout, it's on to the next part, which is adding functionality. Now, the functionality is going to come when the search button is pressed. So I'm going to add a command to this. And the command is going to call a method which I'll call find password. We've got generate password and we'll now have find password. Now I'm going to go and create my find password. And just because we've got all these sections set up, I'm going to add another section, which I'll call find password. Inside this section is where we're going to be creating our find password function. And this find password, let's just check to make sure there were no errors here and we've spelt it the same way. And this find password function is going to need to get hold of the entry that's inside the website entry. So the website that we're looking for comes from the website entry .get, and then we'll be able to get the value of whatever the user typed inside this entry. And then we're going to use that to search through our data.json. Now, the easiest way for this to work is actually to first add a website. So I'm just going to generate a website with my email and password and add it so that it gets saved inside my data.json. This way I'll be able to print things and I'll be able to work with the data a little bit easier. And then we'll address the exception catching a little bit later on. What exactly are we looking for? Well, we're looking to load up the data inside this JSON file. So we're going to be opening up that file. So with open, and then the file name is data.json, and then we'll save this as the data file. Now, once we've got our data file, then we can use our JSON module to load up that file. And we're going to be getting hold of the data that's inside. So we can save this to a variable called data. Now, this data, if I go ahead and print it, you should remember is basically just a dictionary. So as soon as I hit search, that should trigger this find password. And now I've got my dictionary printed in here. So what do we want to do with this dictionary? Well, we want to look through it and check to see if this website that we're searching for actually exists inside that dictionary. The way we do that is we say if website in data, well then in that case, it's actually success, right? We've managed to find it inside the data and we now just need to get hold of the email and password values. So let's create a variable called email. And we want to pick out this particular value from this dictionary. If this is the entire dictionary, then we want to get hold of the dictionary and pick out the item with the key that matches the website that we're searching for, like this. Now, once we've gotten hold of this, this is going to be a nested dictionary. So it's equivalent to basically this part of the dictionary. So this in itself is a dictionary, which you could save to a separate variable, but I think it's actually easy enough to understand that we can tag on another key here, which is the word email, in order to get hold of the value that's associated with that key. So that way, this email variable now saves this value here. And in the same way, we can get the password from data, getting hold of the data under the website key, and then passing in the password key. Now that we've got the email and password, we can go ahead and create our message box using show info. And we'll set the title to be the website that the user is searching for. And the message is going to be a F string, which has the email listed. And then on a new line, it's also got the password that's going to be listed as well. Like that. Now let's go ahead and run this code and make sure that it works. Let's say that we have a couple more passwords that we save in here. Now I should have 3 entries, Amazon, eBay, and Twitter, and I want to go and search for my password for eBay. Once I hit the search button, it goes into that find password function, and if it finds that one of these has the key eBay, then it's going to fetch all of these relevant pieces of data that I wanted from that JSON file. So now what we have to do is to make sure that we catch any exceptions that might occur. And you might already have realized that this works really well right now because we have data and because we have this data.json file. But the first time that I run my program, this is not going to exist. So this is a more realistic version of what the program will look like the first time we run it. And the first time we go ahead and run this and I search for something that is going to look for a file that doesn't exist, immediately our program crashes and we get the file not found error. So what we need to do is we need to be aware enough that these things like opening files can fail. So what we have to do is we have to catch the exceptions and handle them. So let's go ahead and indent this entire block and put it inside the try. Now the part that's most likely to fail, in fact, the first time the program starts, this is definitely going to fail. But what we want to do is we want to catch the exception that is file not found error. And in this situation, what we want to do is we want to create a message box that tells the user this data file doesn't exist. This is just a simple show info, and we'll give it a title of error, and we'll give it a message of no data file found. Or you can put any other message you can think of. However, if we were successful in opening this file, then this is the part of the code that we want to implement. So let's go ahead and bring it up to the right indentation, and we search through our data, look for this website, and then give the user a pop-up if it exists. Now, if we run our code again and we search for something, even though we don't have a data file, we haven't saved anything yet, then we get this error pop-up and it tells us no data file found. And hopefully the user would realize, well, actually, I haven't actually saved any passwords. So there's one other situation that we haven't yet addressed, however. If I had, let's say, Amazon, eBay, and Twitter saved in my JSON file, but I decided to search for something that I never saved. Let's say my details for Facebook. Well, in this situation, actually nothing really happens. And it's a little bit confusing because for the user, it seems like our program just doesn't work. But in fact, we as the programmers know what the problem is. It's basically this if statement is coming out as false. The website doesn't exist in the data, so none of this gets carried out and the function ends. That's probably not the best user experience. Instead, we probably want to catch it with an else statement, and we want to use a message box to tell the user that, again, there is an error in this situation. But the reason for this error is because there are no details that currently exist for the website that they're searching for. That way, they're not sitting there confused as to why searching for some sort of website doesn't actually come up with anything. It tells them that there are no details and they would have to add it if they want to find it in the database. A lot of students might be wondering at this point, well, why don't we catch this with some sort of exception? And in fact, we could create an exception. We could raise an exception here and then we could catch it somewhere else and show this message box. But the thing you want to keep in mind is that if you can do something with if and else very easily, then you should stick to if and else. If you can't do it with if and else very easily, and it's actually an error that's going to be thrown that you don't have any other way of dealing with, then you should be using the try, except, else, finally keywords. And in fact, if you think about this, I don't have an easy way of checking to see if this data file ends up being not found. But I do have this file not found error, which is going to be thrown every time that I try to open a file that doesn't exist. The other way to think about it is that an exception is something that is meant to be exceptional. It's something that happens very rarely. Whereas if and else catches things that happen frequently. It's pretty often that your user might search through the website thinking that they saved some sort of details for a website, but in fact they didn't. Think about this when you're writing your code, and remember that only use exception handling when you don't have an easy alternative. There you have it. That's the completed code for our upgraded password manager. If you want to take a look at any of this code, then as always, head over to the course resources and you'll see a link to the completed code that you can review. But in today's lessons, we added a lot more knowledge regarding things like error handling and saving data in JSON formats and handling and loading and updating and dealing with all of that data in order to create this fully fledged password manager project. Now, I'm sure there's a lot more improvements you can add to this, but it's going to go beyond the allocated time for today's lessons. So if you want, please continue messing around with the code and improving it and make your own customizations and modifications. If you create something that you thought was cool, then be sure to share it with us in the Q&A below the lesson so that we can all admire your hard work and maybe improve our own code as a result. So have fun playing around with this program, and I'll see you tomorrow.